Today we are going to discuss about phenomenon of creep from the perspective of material science and its importance in mechanical behavior of materials. A creep is a kind of special plastic deformation. It is a time-dependent deformation under a certain applied loading. Generally occurs at a high temperature, but a creep can also happen at the room temperature in certain materials such as lead or glass, although at a much slower rate. And as a result, the material undergoes a time-dependent increase in length, which could be dangerous while in service. Creep will terminate in a rupture if stops are not taken to bring it to a stop. Diffusion, dislocation, glide or climb, or grain boundary sliding all can contribute to the creep of a metallic material. It can occur as a result of a long-term exposure to high levels of stress that are still below the yield strength of the material. And creep is more severe in materials that are subjected to heat for a long period and generally increase as they nearing their melting point. The rate of deformation is called the creep rate. It is the slope of the line in a creep strain versus time curve as shown in the figure here. The result of creep test is usually plotted as a creep curve where we plot a strain as a function of time because we are keeping the stress constant. And unlike the stress strain diagram, we have a strain versus time diagram because it is a continuous plastic deformation as a function of time. So in short, we can say a strain is plotted as a function of time, as you can see in the graph here. Independent permanent plastic deformation that generally occurs at a high temperature under a constant loading or stress. It can also occur at a room temperature for soft metals such as lead. Creep is a slow process where deformation changes over time. Creep is very important in application such as a turbine blade in jet engine, gas turbine, and power plants, including boilers and steam lines, where these components must operate at high stresses and a high temperature without any changes in dimension. So now we will be talking some of the characteristics of a creep. So creep in service is usually affected by a changing condition of loading and temperature. The number of possible stress temperature time combination is infinite. A creep mechanism often differ between materials such as metals, plastic, rubber, and concrete. And also creep is a time-dependent deformation under an applied loading. Metals and alloys do not exhibit time-dependent deformation under normal service condition. Metals subjected to a constant loading at elevated temperature will undergo a time-dependent increase in length.